A Lewis structure is a representation of a molecule or polyatomic ion that shows how our electrons are arranged among the atoms. So Lewis structures are representations of molecules or polyatomic ions. Both molecules and polyatomic ions are held together by covalent bonds, meaning that the electrons are shared. And they are all going to be non-metal bonds. So we are only dealing with things from the right side of the stairs on the periodic table and, of course, hydrogen. Lewis structures are going to only show valence electrons because those are the ones that are involved in bonding. In a Lewis structure, you have bonding pairs and you have lone pairs. So a bonding pair is a pair of electrons shared between two atoms. So if I have my fluorines here, let's change colors. Come on. My bonding pair I will make red. And so that's a bonding pair. And then lone pairs are any electrons that are not directly involved in the bonding. So they're around the outside. So all of those green electrons are lone pairs. Notice we're only talking pairs here. When we get into Lewis structures, electrons are always traveling in pairs. This is very important for drawing Lewis structures. If an atom needs one electron, it will form one covalent bond. And when I say needs one electron, what I mean, it needs one electron to become stable, to get to that noble gas configuration. It will form one covalent bond. So this is going to be hydrogen. It's going to form one covalent bond, and then the halogens, which is, of course, group 17, will only form one bond. They have 7 valence. They need one more to become stable, so they will only form one bond. If an atom needs 2 electrons, it will form 2 bonds. That's our group 16. They have 6 valence. They need 2 more to get to 8. And then if an atom needs 3 electrons to get to 8, it will form 3 bonds. That's our group 15. So when you're writing Lewis structures, what you're going to do is you're going to add up how many electrons to use. You're going to add up all of the valence electrons from all of the atoms. You're going to start with just a one bonding pair between each pair of bound atoms, and then you're going to arrange the remaining electrons to satisfy the octet rule. Again, that stable noble gas configuration, typically it's going to be 8 electrons will satisfy the octet rule. Exceptions, of course, hydrogen will always only form one bond. It will have no lone pairs. Never put lone pairs on hydrogen. Another exception that may come up later is boron. Boron is satisfied with 6 electrons for reasons that I'm not going to really get into. Just boron is satisfied with 6. So in a single covalent bond, one pair of electrons is shared. So let's look at that. Chlorine has 7 valence electrons. This molecule is Cl2, so there's 2 chlorines, each one bringing 7 electrons to the party, so that's a total of 14 electrons. We're going to single bond one chlorine to the other chlorine. So I've used 2 electrons, I got to use 14. So this is the part that's really important. You're going to put those other electrons around the outside. So I'm just going to place electrons around the chlorines in pairs until I've used all 14 electrons. So I have 2 in the middle, 4, 6, 8, 10, 12, 14. So I've used 14 electrons. Sorry about that. The next thing I have to check is, have I satisfied the octet? So you may have done this before where you drew circles. I don't usually draw circles because I think it just kind of muddies things up. But the electrons that are in the middle belong to both chlorines. So that first chlorine does have 8 around it. The second chlorine has 8 around it. So they are both satisfied. I've used the correct number of electrons. My Lewis structure is complete. Doing HF, hydrogen has 1 valence, fluorine has 7, so add those together. I can use 8 electrons. Start with a single bond, so 1 pair of electrons being shared between the hydrogen and the fluorine. I have to get to 8, so I need to put in 6 more electrons. Remember that hydrogen cannot have any lone pairs, and so the other electrons can't go around the hydrogen, they have to go around the fluorine. So that's 2, 4, 6, 8. So I've used 8. I gotta check if everything's satisfied. The hydrogen that's all hydrogen can do is make 1 single bond. And then the fluorine has 8 around it, so we're good. In a double covalent bond, 2 pairs of electrons are shared. You will typically only see double bonds with carbon, nitrogen, oxygen, sulfur. Now, things won't be labeled, single bond, double bond in the future, and so we'll just go through how to know that you have a double bond. So oxygen has 6 valence electrons. There's 2 oxygen, it's a total of 12. So put the oxygens next to each other. Start with a single bond. So that's 2. Put the rest around the outside. 4, 6, 8, 10, 12. I've used 12 electrons. I cannot use any more. I have to check if the octet rule has been satisfied. Oops. So my first oxygen, I have 8 electrons around it. But my second oxygen, I don't. My second oxygen, I only have 6 electrons around. So to satisfy that octet, what I'm going to have to do is I'm going to have to take a lone pair off of that oxygen and make it a bonding pair. So let me go back for a second. Every single time you're in the situation that you've used all of the electrons, but something's octet isn't satisfied, you do the same thing. You erase a lone pair, make it a bonding pair. Because when I do that, I haven't taken anything away from that first oxygen. It still has 8 electrons. It has these 8 electrons. But what I've done now is I've shared 2 of those electrons with the second oxygen, so now that its octet is satisfied. Triple bond, even fewer things will triple bond. Typically only carbon and nitrogen will triple bond. So let's do diatomic nitrogen here. Nitrogen has 5 valence electrons. There's 2 nitrogen, so I can use 10. Start by single bonding 1 nitrogen to another nitrogen. That's 2, 4, 6, 8, 10. And it doesn't matter where you put these electrons. If you started it like this, that's still 10. You're still going to reach the same conclusion at the end. There's only one correct Lewis structure for every molecule, and if you follow these steps, you will always find that correct Lewis structure. So it doesn't really matter what you do with the lone pairs at the beginning, as long as they're around the outside. So now I have to check if everything's satisfied. Looking at each of these nitrogens, neither is satisfied. They both have 6 electrons around them. So every time you're in that situation, erase a lone pair, make it a bonding pair. By doing that, the second nitrogen now has 8, but the first one still only has 6. So I'm going to erase another lone pair, and it doesn't matter which one you erase, but I'm going to erase another lone pair, make that a bonding pair. Now they are both satisfied. Everything to this point has been binary. Let's look at what happens when it's not binary, not just 2 atoms. So you start the same way. Nitrogen has 5 valence. Hydrogen has 1. There's 3 hydrogens. So that's a total of 8 electrons. But when something's not binary, what happens is typically things will bond to something called a central atom. There's going to be 1 atom in the middle, and everything else is going to kind of be around the outside. And simplest explanation is the thing that there is the fewest of is going to be your central atom. So there's 1 nitrogen. That's going to be my central atom. My hydrogens are going to go around the outside. Any 3 sides. You can put one on the top if you want instead of the bottom or whatever. Start with single bonds. So single bond the nitrogen to each of the hydrogens. That uses 6 electrons. I need to use 8, so I have 2 more. They have to go on the nitrogen because hydrogen never gets any lone pairs. So I've used 8 electrons. Is everything satisfied? Yes, hydrogen can only do that single bond. Nitrogen has 8 around it. That's a correct Lewis structure. Carbon dioxide, carbon is 4, oxygen is 6 times 2, so that we're going to use 16 electrons for carbon dioxide. Carbon's going to be my central atom. Oxygen's on the side, or, top and bottom or whatever. Start with a single bond between the carbon and each oxygen, and then put the rest of the electrons around the outside until you get to 16. So that's 2, 4, 6, 8, 10, 12, 14, 16. Great. On first glance, you might think that everything's satisfied. Both of these oxygens are good, but the carbon is not. The carbon only has 4 electrons around it. So every time you're in that situation, erase a lone pair. Any lone pair, doesn't matter. It doesn't have to be the top one. Move it to the middle. Carbon's still not satisfied. It has 6 oxygens. Just to prove a point, doesn't matter which lone pair you erase. Erase lone pair. Make it a bonding pair. Now carbon is satisfied, and that is the correct Lewis structure.